All right. Happy homecoming per last week or whatever, and whenever you're watching this, but I'm full of school spirit. So here we go. So last video, we went over all of these special right triangle rules and how a special right triangle can have certain lengths. Oops, sorry about that. It's aggressive. And so what we're going to do is now we're going to apply this within what we call the unit circle. Okay. And so when I am looking at the unit circle, what I want you to understand is there are a couple of things. Okay. The unit circle is a circle on the XY coordinate grid that has a radius of 1. That is why we went and dissected all of the special right triangles that have a hypotenuse of 1, because we are going to take all three of these triangles and place them inside the circle, like you see right here. Okay, so let's just, for instance, kind of dissect this circle right here. If I go over towards the right a certain amount, okay, that's going to be my X coordinate, okay? If I go up a certain amount, that's going to be my Y coordinate, okay? And so what we create are these outer coordinates that are a part of our circle. And so the coordinate P that we're going to talk about has an X coordinate and a Y coordinate. Okay, so it has an X coordinate and a Y coordinate. Now, if I find the sine of the angle, we know from the trig stuff from the last unit, sine is opposite over hypotenuse. So in this case, it would be the Y value over the hypotenuse, which is 1, okay, which we know that we can write as the Y value. The cosine is adjacent over hypotenuse, and this theta's adjacent leg is the X value over 1. And so we could simplify that and say that the cosine of the theta is just the X coordinate. Now, tangent, a little bit trickier. We have opposite over adjacent. So that's going to be the Y over the X. Now, that does not simplify at all. So we leave it Y over X. Or some people say that it's like the sine of theta over the cosine of theta. So because those are kind of the same thing. But I like the Y over the X. So the coordinate of P could also be written as the cosine of theta, comma, because that's the X value, comma, the sine of theta. So if I ask you to find the cosine of a certain angle, you would look for the X coordinate. If I ask you to find the sine of a certain angle, you would look at the Y coordinate. And if I ask the tangent, you would do the Y value over the X value. Okay? So I gave you a little dissected piece of the unit circle because if you kind of peeked ahead, you do know and see kind of, ooh, it's a little crazy, okay? It's a little crazy. So we're going to just look at in the first quadrant. So this is the first quadrant right here. Oops, I don't really want to do, actually, I don't even want to write it right there. Let me change my mind. Let me change my mind. Okay, so here's this one right here. That's why it says one, because if you look in the big picture, there's like 1, 2, 3, 4. Okay, so in the coordinate grid, this is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. Okay, those are Roman numerals, but those are the quadrants. Now, riddle me this. What are the coordinates that fall inside of the first quadrant? What are they always? Good. Positive, positive. They're always a positive value and then a positive value. Both X and Y are both positive. Okay. The second quadrant. Very good. Negative, positive. Because if I go to the left, then that's negative. And if I go up, which would fall inside the second quadrant, that would be positive. Okay. The third quadrant would be negative, negative. And then the fourth quadrant would be positive, negative. So I want you to think about those things when we go into the bigger circle. But that is helpful because we're about to look at the first quadrant. Okay, so we know all of these values are going to be positive, positive, because all of these are contained within the first quadrant. Now, I told you that this radius of this circle is 1. So if I start, this is the origin right here. And if I go to this point right here, that's at 0, 360 degrees, right? Because it's 0, that's my initial side. If I go all the way around the circle, that's 360. This coordinate would be 1, 0. Okay, because my unit circle, my circle has a radius of 1, and then I go up none. Okay, let's do the other easy one. If I'm at the origin right here and I want to do the 90-degree angle, okay, because again, I'm going from the initial side all the way this way, counterclockwise, gets me a positive degree. This would be 0 because I would not go left or right any, but I'd go up 1.